myself Sudharshan from 30 years CS AIML from Christ University. The project title of mine is like AI sign language interpreter. What is a sign language is nothing but just some people having like hearing impaired people, so that the sign language is the one which what makes them to communicate each other. So what my AI sign language is all about, like it's an real time scenario where you show your fingers, it will detect the words or the sentence what you are doing, and it will enhance with AI. Like I just think you are saying hello myself version. The words are like continuous, as my model is prepared like that, so that my AI will translate that text to a proper sentence. That is all. That is what it's all about. The main objective of this is to help the people who is like who don't know the sign language or something, so that the sign hearing impaired people can talk or communicate with other people too. So the main idea of I solved a challenge. This is a challenge which we face. So I solved a challenge using this sign language AI sign language interpreter. At first, let me explain you the code. I use Book for training my model. I use Book for my training my model. First, this cell is all about like importing the things where image data generator where to balance my data, and mobile net V3. This mobile net V3 and efficient net V2 is the two models which are used for deep learning or CNN models. Where like here in mobile net V3, this is an CNN model which is a newer version, which is the things which is used. This is the model, operated model which we use when we have low computational devices or when you have data set very less complexity. So we'll go with this mobile net V3. And efficient net V2 is other model which I used for Indian Sign Language, where Indian Sign Language is using in two hands, where American Sign Language which uses only one hand. So Indian Sign Language is somewhat complex. So I went for efficient net V2, which can handle that complexity because of its like a lot of parameters there in it. Yeah. This is my image size. This is for ASL training. I used mobile net V3, so that I used 224, 224 is like the pixel size. This is for training data generation, where see mobile net V3. I imported that and I generated some data. These are the classes. My whole project is completely about supervised machine learning, where you show some fingers. Like imagine you have some fingers, you are showing some fingers. As we know, like supervised machine learning is all about like labeled data. So my labeled data is here. If you show some like if you show some fingers or the hand you show, so it will classify based on the labels. That's how your output is predicted. Yeah, these are like some sample images for my data, where this is A, this is Q, this is space. If nothing there, it's nothing, but there is nothing. Yeah, these are the 7 layers which I used. Layer 1 is like input layer, where you do your input layer. After that, my main architecture is like you will give the input through OpenCV. OpenCV is nothing but this is the basic library we use for computer vision, where it will take the images or videos or whatever it is you are showing, you are giving an input, and it is slowly converting or like pixelation or processing the image, the pixels. These pixels will then go to the media pipe. Media pipe is nothing but it is one of the visioning tool, where just think you are showing your finger. So the media pipe will show some landmarks over your hand. So that based on the landmarks, it will predict what is the output. And this pooling is nothing but like just imagine you have a large data, but there is some insufficient data in your data set. So what it does is, instead of pulling everything into it will drop something which is not important in the picture, in the image. This is where I trained my model using above 30. 30 is nothing but like how many times it should go like look through or run through all the data. This is the training accuracy and validation accuracy, where training accuracy is more and validation accuracy is less. There is a lot of difference. So I tuned it. I tuned the hyperparameters. Yeah, I tune the hyperparameters here so that I get more accuracy and validation output. And when it comes to ISL training, the same thing. Just the difference is efficient net B2, which can handle complex images. This is also in CNN model, which handles complex images. As our Indian sign language includes two hands, but American people as having only one hand to communicate each other. So this is as a complex. So they should detect two hands. So I use efficient net B2 for more complexity. And here image size I take in 260, 260 because like two hands should be sufficient in a pixel so that my output will be so proper enough. It's the same label, the label data I used here. And this is the example. These are the landmarks which will be like generated by your media pipe. The same layers I use here, 7 layers. I use something concept called softmax. Here, whenever you are giving an input, just think you are giving for like an input. Just think the model is thinking like there can be four outputs. Just think A, B, C, D. It will give the percentages like 98%, 2%, 1% like this. The softmax will take the maximum percentage which we got and provide you an accurate output. That is what softmax is. Yeah, this is all my training methods. And here you can see the training VSL validation. Here also I have more differences. Still I fine tuned it. Yeah. When it comes to this product, yeah. First, let us start with uploading an image. This is all my training data, testing data. You can see that. Actually, I uploaded a normal image, but my media pipe had been marked the landmarks and gave it as output H. That is, this is in ASL. This is in like American Sign Language. If you also wanted to shift, what happens is if you upload some images in it, just think you're uploading. I am this. Hello, I am Sudarshan. The words will be like continuous. This is where I use AI to just split the data and give you an communication, like better communication. That is what even I can go for video recognition, where you can upload videos and just get an output like uh, what is the sign language refers to. Hi everyone. Today we're learning the You can check that it's processing the frames of the video continuously and it's giving an output based on the frames what she's showing. Yeah. You can see that the output is coming here. Let's get started. Okay. Like this, it will continuously process the whole video and it will give an output to you. In the same way, let me show you a real time scenario. This is where my whole project on OpenCV comes into picture. Yeah, you can see OpenCV is the one which is capturing my video and it will process it. Okay, as I'm using American Sign Language, we use only one hand. Just think this is it detecting the hand. You can check it. You can see this is in ASL, this is nothing but W. You can see it's predicting W and it's also printing over here. This is my previous testing data, like it's printing over here. And after that, you can use a like enhanced translation. Based on that, it will enhance the translation and it will give you a proper word. That's how it works. In the similar manner, I also developed the same thing for Indian Sign Language. I also use for Indian Sign Language where we use two fingers, two hands instead of one hands. I'll show you a real-time scenario for this also. You can check. This is B. This is B in ISL. This is my evaluation board where you can see everything from scratch. Like from the modeling, I use for ASL, which is American Sign Language, which I use Mobile 8v3, which is a CNN model, and for ISL, I use Efficient at V2. And you can see the accuracy. You can see the input resolution, 224 pixels. As my ISL is having only one hand, so I use less pixels than why to make complex. So, but Indian Sign Language is more complex because we are using two hands. So just to for more clarification, I use 260 pixel, close to 260 pixel, and my validation accuracy for ASL is 93.4 and ISL is 97.5. You can check I got more accuracy for ISL. Like it's because like ISL is like more complex and I try and fine tune it more. So like it's a previous model which is developed by Google itself. Both the models are developed by Google only. Efficient bit we can handle complexity, more complexity. Yeah, this is my accuracy graph where you can see here why it is lower, why it is high, why it is lower. It's because like for optimizing real time speed and as well as small amount of accuracy for extreme like good answers. That's why this is main accuracy graph where you can see this is speed graph. You can check. This is efficient at V3. This is giving more speed answers than this like the time complexity. The you can see that the mobile language is somewhat slow because it's not that complex, like it cannot handle complex. But efficient at V3 is like it's a deeper and more what you can say, it's like neural deeper. It will go depth for the neurals and it will give the answers more accurately. In the same way, you can see my training is it's all about you can download this. This is my performance matrix for both the models where you can see here my validation accuracy is 93.4 and here for ISL is 97.5. The total parameters or the weights I trained. Actually, how I trained the model is like I taken a pre-trained model which is an efficient at P2 or a mobile at P3. I used a concept called transfer. What it does is it actually trained the model is actually trained from the internet from taking like million of like some Google images. After that, I just added my weights. I freeze the backbone. What it does like is instead of giving just think the mobile net V3 is trained from some dog images or something like that. So that I freeze them and I train my data set to the model and after that I unfreeze them and make it to learn. This is what like transfer method is all about. This is my parameters. This is parameter count, model file size. This is confusion matrix. I use heatmap for this confusion matrix. You can check the first A is about 192. That means it is like giving correct answers up to that. What is the confusion? This matrix all it says like for A. Just think you gave an input as A. It's giving like 182% of A. The remaining like B, what's the percentage of B, what's the percentage of C. So based on this only, as I said, like softmax. From that, it will select the most like high accuracy output, and it will give you. After that, my AI will make it for like more communication easier. This is classification report where this is a precision, recall, and F1 score. We can check for individual element and everything. This is my values for A, how much precision I got, what is the recall percentage I got, what is the F1 percentage I got, and everything. You can also add an export thing where we can export everything. Yeah, here there's a button which can like change to ISL and ASL. You can change anytime you want. Yeah, this is all about my project. Yeah, thank you everyone.